Distillation is one of science's oldest pursuits. As early as 1500, Hieronymus von Braunschweig was a well-known author of Das Buch zu Distillation, a 3-volume collection that was translated into German, English, and Latin, and contained methods and apparatus of distillation, along with traditional herbal pharmacopoeia and plant remedies made by distillation. Distillation was not only part of early science, but it was also a central process to alchemy, one of the original science religions. The Emerald Tablet is an ancient text supposedly written by Hermes Trismegistus that contained the secrets of Hermeticism. This text was translated by many people over time, including Sir Isaac Newton. The tablet refers to distillation as the 6th process in the pursuit of the Philosopher's Stone. As in modern chemistry, it was recognized that the boiling and condensation of a fermented solution increases its purity. The tablet states, "It rises from the earth to the heaven and descends again to earth, therefore combining within itself the powers of both above and below." In alchemy, the process of distillation refers to not only chemical compounds, but also to our psychological sense of self, our thought process, our physical and energetic physiologies. Over the past 5 centuries, distillation has improved in its methodology. However, the same principles still apply. You can see in all of these there is a source of heat, a distilling flask, a condenser, and an ice bath, as well as a separate vessel to collect the material in. Along with modern technology, we've developed thermometers, vacuum adapters, but you can still see the basic apparatus at work. Hickman still. We've added 5 ml of water with red food coloring to 5 ml of acetone. Put this in a 25 ml round bottom flask. You can see the liquid boiling away. Added it to a glass adapter with a plastic screw adapter. And here's the Hickman still. You can see the distillate in the collar is quite full, and the thermometer adapter. In just a minute, we'll pipette out that liquid, achieving the purification of the lower boiling compound from the higher boiling compound. Simple distillation separates liquids boiling below 150 degrees Celsius at 1 atmosphere from non-volatile impurities and from each other. The liquids need to be able to be absorbed into each other for simple distillation and have boiling points at least 25 to 40 degrees apart. We're using acetone, which has a boiling point of 56 degrees Celsius, and water with a boiling point of 100 degrees Celsius. Currently, we're boiling at 55 degrees. However, in modern chemistry, there's often times when the amounts one is working with are on a microscale, and the resulting products would be lost by a large distilling apparatus, such as shown before. Therefore, a microscale distillation system was devised for volumes in smaller ranges. The Hickman still was created by Kenneth Hickman in the early 20th century. The still functions like an air condenser, condensing vapors with the cool glass surface. The condensed liquid then drips down and is collected by a collar to be pipetted out. Here we're recovering our acetone, separating it from the impure food coloring and other tap water impurities. The still was slow to start its distillation process, so we put a tinfoil collar on it to warm up this area so that the condensation and evaporation would be more effective. Here we have our glass adapter, and you can see the plastic screw adapter, and a tiny little column with some fractionated distillation area, and then the condensing chamber and collecting collar. The Hickman still can be used in many ways to purify solvents, carry out reactions, and concentrate solutions. As this uses such a simple short column, it may take more than one cycle of distillation to have a complete separation of product. As you can see, it is quite effective though, and follows the classic distillation mechanism.